Yo, good day everyone. You are welcome back to Class Bridge. So very quickly in this lesson, we dive into a crucial aspect of vector analysis, which is the coplanar and collinear vectors. You see, when we have a vector that has both magnitude and direction, that vector can be coplanar, which means they lie on the same plane, or collinear, which means they are lying along the same axis, right? Just like we have here, A, B, and C. They are all lying on the same plane. Can you see? Very good. Now, we can also have collinear vectors. And when we talk about collinear vectors are coplanar vectors, right? But they are lying along the same line. Can you see? They are lying along the same line. So by definition now, we can simply say vectors are said to be coplanar. Right? If they lies on the same plane. Right? Now, for collinear here, they are special case of coplanar vectors. Right? They are also lying on the same plane, but they are lying along the same direction. Do you get the logic now? The special thing about collinear vectors is that they are lying along the same plane and the same direction. So we can say collinear vectors are coplanar vectors that lies on the same line. Is as simple as that, right? Which means that collinear vectors are subset of coplanar vectors. Every collinear vectors are coplanar, but not every coplanar vectors are collinear vectors. But in calculation, they both have a triple scalar product, which is equal to 0. Right? So what do we mean? We are saying if we have a vector A, vector B, and vector C, their scalar triple product is equal to 0. So how do we represent that mathematically? So it means that A dot B cross C is equal to 0. It's as simple as that. Now, given A to be equal to x1i plus y1j plus z1k, and B is equal to x2i plus y2j plus z2k, and also C is equal to x3i plus y3j plus z3k. Mathematically, it means we'll be having A dot B cross C, which is our scalar triple product, is equal to x1, y1, z1, and also we have x2, y2, and z2. And also for C, we will have x3, y3, and z3. All of these equal to 0. It means that when we find the determinant of this matrices here and it is equal to 0, it means that the vectors are coplanar vectors. So now let's see some examples. Now we want to show that these three vectors A, B, and C are coplanar vectors, right? We already know that mathematically we can say the three vectors are coplanar vectors if their scalar triple product is equal to 0. So we have to show that their scalar triple product A, B cross C is equal to 0. If their scalar triple product at the end of the day is equal to 0, then we can confirm that they are coplanar vectors. But until then, we have to show through our calculation first. So A, B plus C is equal to. Here we are going to be having -4, -2, and 2. For B, we will have the coefficient of I is 1, the coefficient of J is 2, 1, 2, 1. And for C, we will have 1, -1, -2. Then we look for the determinant. Don't forget that here we will have plus, minus, plus. Right? Let's go. So A, B cross C will just be, here we have -4 into, when we cross this out and also cross this out, what do we have left? 2, 1, -1, -2. So for the first row, second column now, we have minus into bracket -2 when we close the first row and the second column, what do we have left? 1, 1, 1, -2. The last but not the least, when we close the first row and the third column, what do we have left? There we have +2, we are left with 1, 2, 1, -1. We cannot say that we have 2 by 2 matrices here and we already know how to find their determinants. So here we'll be having -4 into 2 times -2. That will give us -4, right? Minus 1 times -1. That will give us -1. Here now, minus times minus will give us +2 into bracket 1 times -2, that will give us -2 minus 1 times 1, that is 1, plus 1 times -1, that's -1, minus 2 times 1, that's 2. So we are moving forward. Here now we have -4 into bracket We have minus 4 here. Minus times minus, that should be plus. Plus 1 plus 2 into bracket minus 2 minus 1, that is minus 3, plus 2 into bracket minus 1 minus 2. Here we have minus 3. So we are pressing on. We have minus 4 into bracket minus 4 plus 1, that's minus 3, plus 2 times minus 3, that's minus 6. 2 times minus 3, that's minus 6 plus minus 6. We already know that plus times minus is minus. Plus times minus is minus. So we have it to be minus 4 times 3 will give us plus 12. Plus times minus, that's minus 6. Minus 6. We have that's equals to 12 minus 12. Right? Minus is minus is, that's minus 12, which will be equal to 0. So we have confirmed that our scalar triple product A, B cross C is equal to 0, which means that the three vectors A, B, C are coplanar vectors. It's as simple as that.